So you remember back when you first learned about inequalities, you learned how to draw something like x is greater than 1 on a number line. And so you go number line like this, you go 1 is in the middle, and greater than would be going in that direction. Remember doing that kind of thing? So that's kind of a one-dimensional diagram because it's an x, only the x is the only pronumeral in that equation. These ones are two-dimensional. They're going to have x and y, but it's a similar type of thing. We're trying to find the region that satisfies the inequality. So to do that, there's a few steps that you need to do. So let's read through. It says the graph of an inequality represents a region on the Cartesian plane. For example, to graph the region represented by y is greater than x plus 1, so if that was what the region we're trying to graph is, first of all you want to draw just the line of y is equal to x plus 1. So ignore the inequality part for a minute and just sketch that straight line. So the y-intercept of that line is 1. So I'd go y-intercept at 1 and I'd put that right there. And the gradient, which is in front of the x, would also be 1, which means I'd rise 1, run 1 on there, and I would get those two crosses. And I'd join them up. Now, back to my little diagram up here. Remember how sometimes we had open circles and sometimes we had closed circles? Well, we need to be able to identify the difference between when it has an equal to sign and when it doesn't on this kind of graph as well. So when it is a less than or a greater than sign that we're sketching, then we're going to draw a dotted line to indicate that it is not at that line, but that's where the boundary is. If they have the equal sign on them, then we draw our normal solid straight line. Does that make sense? Okay, so this one, when I look back to the original equation there in yellow, was a greater than sign, no equal to, so that is why there's a dotted line drawn through those two crosses that I've made. Okay, so that's step number 1. Draw the line and work out what kind of line you need to draw, either dotted or solid going through them. Then you need to work out which side of that line is going to be the region for you to shade. Now to do that, we test a point. Thank you. So it says here, once the line has been graphed, we need to shade in the side where y is greater than x plus 1. To do this, we choose any point that we like, as long as it is not on the line. Okay, we want to choose something next to it because we're trying to see which side to shade. If we choose something on the line, then it's not going to tell us which side is the correct side. Okay, so in this case, we will choose the point 0, 0. And that is the easiest point to choose. It's always easiest to substitute in zeros as long as your line does not go through the origin. Okay, so here is my equation, y is greater than x plus 1. And I'm subbing in that x is 0 and y is 0. So I get 0 is greater than 0 plus 1. Now, 0 plus 1 is just equal to 1. And I end up with this little sum here that says 0 is greater than 1. And I want to know whether that is true or whether that is false. Is 0 greater than 1? No, it's not. It's smaller, isn't it? So you'd write next to that, that's actually false. That doesn't work. If you sub a point into your inequality and it says false, it means that the point that you subbed in is on the wrong side of the line. So I subbed in 0, 0. I subbed in this one here right on my origin. So that bottom side of that line is not the region I want. I want the top side. Okay, which is why I can see in this next diagram, the top part is shaded. You can retest. You can test as many times as you want. You could go and choose another point that is on the other side of that line. So you could sub in something like 0, 2 or 0, 4 or minus 3, minus 3, 5. Anything that's going to end up in that top part there. If you sub that in, you would hopefully get a true statement that goes, yes, that is the right side of the line to shade. But once you do it once, you kind of know, so you don't need to do it more than once. All right, let's practice that. So the first couple of examples are kind of practicing some of the individual skills building up to the big question at the end. So the first question is practicing subbing a point into inequality to work out whether it is true or false. Okay, so the point we're going to choose is the point 2, 3, and the inequality we've been given is 2x minus y is greater than 6. So I sub the point in. X is 2, so that's 2 times 2. Y is 3, so minus 3 is greater than 6. Okay, just subbed it into my equation. So all that stuff on the left-hand side, I want to work out what that equals. 2 times 2 is 4. Minus 3 is greater than 6, and 4 minus 3 is 1. So I come down to the simplified expression there, 1 is greater than 6. Is that true or is that false? It is false. Okay, so that would tell us that that point is on the wrong side of my line, and I would shade the other side. But we're just practicing that part for now. We don't actually have the graph yet. Let's practice it again. So second question here, we have the point 1 minus 4. We're going to sub it into that equation. So that will become 5, instead of x, it'll be 5 times 1 plus y is minus 4. So I don't actually need the plus. The plus minus makes a minus 4 is less than 6. 5 times 1 is 5. Minus 4 is less than 6. And 5 minus 4 is 1. Is 1 less than 6? True or false? True. Okay, so that is true, which means that point that has been selected was the correct side of the line to shade, which you will do further down. So here it is, question 2. The graph has been drawn for you, which won't happen in your test, but we're just practicing for now. Shade the correct side of the line to make this inequality true. So the line's drawn there for us to save us that first step. So we're trying to work out which side of that line to shade. We need to test a point. You can choose any point you like as long as it is not on the line. Anyone want to make a suggestion?
0, 0.
0, 0. Okay, so 0, 0 is not on the line and it is the easiest point to sub in. So it's my favorite choice as well. Let's do that. So over here on the side, please make sure that you always write this down, like you show your testing. Marks are allocated for it on your test. So make sure you show what you've tested and you're working out. So I'm testing the point 0, 0. So I'm subbing into this equation. X is 0 and y is 0. So that is 0 plus 0 is greater than or equal to 1. Well, 0 plus 0 is still just 0. Is 0 greater than or equal to 1? Nope, it's less than, isn't it? So that is false. So if I had tested the origin, that little point that I've drawn there in green, and it is false, that means that point is the wrong side of the line to shade, so I shade the other side. The region will be on the top side here of that line, and that's it. That's what we need to do. Okay, so question 3 is the complete package. We've got to do all the steps. We've got not 1 but 2 inequalities there that we need to draw and sketch the regions. So let's just do one at a time. So first of all, let's start with this one. Y is greater than or equal to 3 minus x. So the first thing we do is we sketch that line, ignoring the inequality part, just by finding the y-intercept and the gradient. So what is the y-intercept? 3, good, it's the number that's by itself. So on my graph, 1, 2, 3 is going to be there. You don't need to label every number on your axes, but you do need to show where the intercept is. What is my gradient?
1.
Not just 1. Negative 1. What would be the rise and the run if I had a gradient of negative 1? Rise 1, run 1, but to the negative side. So from that 3, I'm going to rise 1 to 4 and come across 1 to the left, to the negative side. So I've got my 2 points. I'm going to draw a line through it, but before I do, I have to stop and check what kind of line. Is it going to be dotted or is it going to be solid? Now, looking at my equation, I have the equal to sign on it, which means solid. Remember me drawing that little thing on the top of the last page there? So we want to draw a solid line, preferably with a ruler, going through those two crosses. It's always a good idea to extend it out much longer because there's going to be a second graph there that we want them to intersect. So you can make it quite long. Oh, here they come. Quick, coming in. Oh, it's locked. Thank you, Toby.
Thank you.
Well, we've already started, girls. You'll have to catch up. Okay. Before we move on to the second line, we've drawn the first one, but we still have to work out what side of the line to shade. So we now test a point. Any point that's not on that line. What should I choose? 0, 0. You chose my favourite. Okay, so I'm going to do that over here. Do my working out. Show what I'm doing. So I'm going to test the point 0, 0. Okay, into that yellow equation. X is 0 and y is 0. So y is 0 is greater than or equal to 3 minus 0. So that's 0 is greater than 3. Is 0 greater than 3? No, it is not. It is false. Okay, that means the origin, which is down here, is the wrong side of that line because it was false. So I want to shade the top side of that line. Now, because we're doing two graphs here, only do a little bit of shading because we want to see which part overlaps with the two of them. So I'm just going to do a little bit of shading down there. Actually, I'm going to make my line a bit longer down here. There we go. Keep shading all the way down here. Okay, just a little bit. Now let's do the second one. So the second line was 2y is less than x minus 2. Now, remember I said we want to find the gradient and the y-intercept. At the moment, I can't read that from that equation. I need to get y by itself. So let's do that. Y is less than, I'm going to have to divide everything by 2 to get that y by itself. So that's x divided by 2, or in other words, half x. And minus 2 divided by 2 is minus 1. Okay, so from that I can read off my gradient and my y-intercept. You can write them down if you like. M is going to be equal to a half, and the y-intercept is going to be equal to negative 1. So let's plot those on the graph. Starting with the y-intercept, negative 1 down here. Then the gradient of a half means we rise 1, run 2 to the positive side. So up 1, across 2, intersects there. Okay, we're going to draw a line, but what kind of line? Dotted or solid? Dotted, because this one didn't have the equal to sign on it. So dotted line, you guys, I'll go back and explain the beginning for you. You'll just have to wait a second, please. We're nearly done. There's my dotted line going through those 2 points. Okay, last thing is to test which side to shade for that one. Okay, what should I test? Love it. Testing 0, 0. You can test other points. All right. You sure we don't want to test a different point? Oh, I'm going to stick with 0, 0. Okay, testing 0, 0. Into my blue equation. X is 0, y is 0. So 2 times 0 is less than 0 minus 2. 2 times 0 is 0. And 0 minus 2 is minus 2. Okay, is that true or false? Is 0 less than minus 2? It's false. 0 is bigger than minus 2, isn't it? So that means that the origin is the wrong side again. So we want to shade on the bottom side of that line. Okay, once you've done those little bits of shading, when there's 2 graphs, or sometimes there might be 3, there could be more than 2 graphs, you want to find the region that is common to both of them. Okay, and you can see that both of these graphs have this section in here where those shaded sections are pointing towards each other. So that part that I've shaded in orange satisfies both of those equations. Any point in that orange section would be a solution to both of those equations. Inequations, I should say. Okay? Now this is a very important skill. The biggest marks for the test is from on this. I think it's worth 6 marks from memory. Okay? You need to practice this, so make sure you do it on the test. Remember, on your exercise, sorry. Make sure, as I said, that you show the testing, and be careful with your sketching and dotted lines and solid lines, those kinds of things.